Hello, welcome to my channel. Those who are new, I'm Mr. Fernando. I'm a SAP Integration Architect. And in this channel, I'm trying to break these complex integration topics, especially when it comes to SAP, and simplify these integration topics for you. So today's topic is on JDBC adapter in SAP Integration Suite. JDBC adapter enables you to connect SAP Integration Suite to either cloud or on-premise databases. So if you want to build an interface from SAP Integration Suite and connect to either an on-premise SQL database or a cloud database server, you can use the JDBC adapter. Here, when you are connecting to an on-premise database server, you have to go through the cloud connector. You first have to configure the cloud connector, then through that, you securely connect to your SQL on-premise database. But if the database you are trying to connect to is on cloud, you can simply configure the JDBC adapter in the SAP Integration Suite to connect to your cloud database server. For the purpose of demonstration, for this video, I will use a SAP HANA cloud database to show you how to connect and how to invoke different SQL statements. In this example, we'll first of all establish a connection to the database server, which is a HANA database server on cloud. For that, first of all, you have to maintain what we call the JDBC security material in SAP Integration Suite. So we'll go through those steps. Then we will configure the JDBC adapter and establish the connection. We will also look at how to invoke these different statements using a direct SQL statement from our connection or using this SQL XML formats. Then we will go into more details like how to execute multiple statements using this batch data configuration. And also in the adapter, we have a configuration called atomic and non-atomic for batch data. So we will look at the behavior of atomic and non-atomic configuration. As we talked about, for this example, I will use a SAP HANA Cloud database. On my BTP account right here, I have subscribed to SAP HANA Cloud service. So let me open that application. And here I have provisioned a SAP HANA database server. So here you can see the type is SAP HANA database. And you can see the versioning and other information like memory and storage. And if I go further, you can see the overview of my database, the memory usage and the consumption and things like that. And also some of the configuration that I have enabled. So here the database user is DB admin. I will need this when I'm establishing the connection. So here I need to make sure my SAP HANA database is in a running status. So if you go to actions over here, you can stop the database also. So make sure the database is running. And if you want to go to the database tables and to the developer cockpit, you can open up the database explorer from here. Here you will be able to see different catalog objects that is available in your HANA database. For example, the tables, the stored procedures, and things like that. For this demo, I will use this S-Flight or flight booking data model provided by SAP. So here we have a nice data model where it simulates a flight booking engine. So here we have the customer information, the flight booking information, the flight details, and some airport details, the master of the airports, and flight schedules. And this data model and these different tables we will use in this example. So let's try to find one of the tables underneath this data model. So let's search here, S-Flight, and you can see the different tables under S-Flight. But if I want to see the data of this table, the booking table. You can right click and open data. So here we have the data records of that table SBook. And to create a simple query, I will go to analysis. Let's select from this table the booking ID, carrier ID, and maybe the customer type and the class and the passenger name. To see the SQL query of the filtration that we did, you can click on here, SQL. Now here is the SQL that is relevant for our filtration. To keep it simple, I will simply copy this part where I select these columns from this table. Let's ignore the group by and order by for now. And if you want to run this SQL, you can go to this SQL console and paste the SQL query here, and you can run it. Here is the result set of our query. For the first example, we'll try to execute the same SQL query from Integration Suite through our JDBC connection. And then we will go into SAP Integration Suite. So the first step, as we talked about, is to maintain a JDBC security material with the connection detail of your database server that you are trying to connect with. So go to JDBC material. From here, we will create a JDBC data source. Since we are connecting to a SAP HANA database, we don't need a JDBC driver. But let's say if you are connecting to any other third-party database servers like Microsoft SQL or Oracle, you first have to install the JDBC driver. So go here, select the database type, Oracle, DB2, either SQL Server, then select your JDBC driver file, then deploy that. But since this is a SAP HANA Cloud database, we don't need to perform this step. And we can simply create a JDBC data source. So click on it, give it a meaningful name. I will call it HANA DB. And then we have to select the type of database. In this example, our database type is SAP HANA on cloud. So we'll select that. But if your database is an on-premise database, you will select this. And then you will see you have the location ID. This is where you will configure the location ID that you define in the cloud connector. So as we talked about, if your database server is an on-premise database, you have to go through the cloud connector. And in the cloud connector, you will create a location ID. That is what you will define here. But our database is on cloud, so we'll select that. And what is the username of the backend database? So here the username is dbadmin. So I will copy that. And I will assign it here. So here I will provide the password. Then we have to provide the JDBC URL, what we call as the SQL endpoint. If I go to the HANA Cloud, and from here I can see the SQL endpoint. You can simply copy it from here. Or with the actions, you can go to copy SQL endpoint. And that endpoint that we just copied looks something like this. You have a host. This is the host of your database server. And then you have the port. But when it comes to the JDBC URL, you have to define it in a certain pattern. You can find that pattern in SAP Help. And here you will see what are the different patterns that we have to use for this JDBC URL. So here, since our database is a SAP HANA Cloud database, we have to add this part to the beginning of this URL. So if I go here, this is what we copied as the SQL endpoint. And here I have to add this part, JDBC SAP. So this is the complete URL path. So this is the path that we just defined. And at the end, you have the port. So now we can deploy this JDBC data source. The data source is successfully deployed. Now we can move on to configuring the adapter. Before that, I wanted to show you for different database types, you have different URL patterns. In SAP Help, you can see them. So for example, for a DB2 on-premise connection, you have to set the URL in this pattern. And for a Microsoft SQL, let's see, it should be in this pattern. Now it's time to establish the connection to the database through an integration flow. So I created this simple integration flow, and for the endpoint, I named it as HANA DB connection. So to establish the connection, we need a receiver. Receiver now is our HANA database. So let me rename this as HANA DB. And to create a connection through JDBC adapter, we need a request reply step. Under external calls, you can add a request reply step. Let's call this HANA DB request reply. Then from here, let's create the connection. Now we will select the JDBC adapter. And then let's go to connection. And here we have to provide the database source that we configured in the security material. What is the name of our JDBC data source? Okay, seems like I have done a small spelling mistakes. Should be HANA database. Let me undeploy this. Then I will create a new JDBC data source. Let's undeploy this. This time with correct spelling. HANA DB, HANA Cloud, DB admin is my database username. Password done, password added, then the URL. Let's deploy. This is what we have to provide in the data source in the adapter. Over here, rest of the configuration, let's leave it with default values for now, and let's deploy. Now that our interface is active, let's test it through Postman. Here is the endpoint of our integration flow. And in the body of the message, we'll provide the SQL query. And we will trigger the same SQL query that we tested out. Now through the integration suite, the integration flow. Now paste it here. Now this is a direct SQL query. And through our connection, let's trigger it. Right. In the response message, we can see the result set. If I change the format here to XML, we can see the result set. So we have the response and each row in a different segment of the XML message. And also each column that we selected 5 columns, and the values you can see here. And you can see the full result set here. The same that we get over here. Now we successfully established the connection through the JDBC adapter to our HANA Cloud database. Here we used a direct SQL to send the request to the database. However, when it comes to integration, we usually use a SQL in XML format. So how does that format looks like? So here you have the XML format that should be sent in the request to execute a select operation. Same way you have for other actions as well, for delete, insert, update, and executing a stored procedure. So I converted the same direct SQL statement that we used before into this SQL XML format. So here we have to provide the action as select. That is the select statement. So here we have the column names, and here we have the table name and the statement or the action. Let's trigger it. Now we get the results back. So that we don't have to change the format every time, I will add a content modifier with content type to our integration flow. So I added a content modifier over here, and the content type, the header parameter, I'm setting it as XML so that we don't have to change it every time in Postman. If we trigger it again, now we get the same results with this SQL XML format. So this is the format that you have to use, but some of these header segments doesn't have to be strictly these names. Let's say I can have the root element rename like this. It should also work. Right. Still we are receiving a response. And also the statement name, we can rename like this. Let's see if that works. But if we change this segment right here, let's say we'll call it DB table. So now we get an error. And if I go to the message monitor, I can see the error right here. So the format that we sent is not compatible with the database. So I will change it back again to table, and it should work. So when you are using this SQL XML format, make sure to have the mandatory segments as it is. And the format looks like this. Now, what if we want to add a where condition to our select statement? Let's say I want to select only a certain carrier. Let's say LH. I believe it's Lufthansa. So I will add it here. Carrier ID equals to LH. Let's run it. Now we have the filtered result back. We have the bookings under carrier ID LH only. Of course, this one you can use it as a direct SQL. So as a direct SQL also, you can use it. But however, what we want to find out is how to insert this where clause in this XML SQL format. To insert a where clause to the select statement, we have to define the key. This is the format. So we have to define underneath the key the column name that we want to filter by and the value. So we want to filter by carrier ID when the carrier ID is equal to LH. We trigger it. Now we get the filtered result back with our where condition. We only have the carrier ID LH in the result set. What if we want to add another where clause with AND? Let's say I want the carrier ID as LH, and also I want to filter by class Y. So I can add another statement over here. This time we are filtering with class. So class equals to Y. So now in the where condition, we defined the AND condition. Carrier ID equals to LH and class equals to y. So the where condition we define in that SQL format is similar to this. Query ID is equal to LH and class equals to y. But if I want to add another condition, I want to select either class y or class C. So let's define it here, or class equals to C. Now we get the results with either the class C or Y. How should we define it in the SQL format? So here we define a AND condition, but to define an OR condition, you have to create another key segment. So we have to add the OR condition like this. It is in a separate key segment where class equals to C. Now we get the result set. We can see class Y is here. Let's see if there are records with class C as well. Right. We get the result set with class C and Y. And here is the XML format, how we define the where condition with AND and OR logical operators. To show insert, update, and delete actions, let's use this as custom table. This is the customer master of this flight booking application. So here you have the names, the addresses, and the telephone number, and some customer master details. So we will try to insert a new entry with a new customer ID. Now here is the format to insert a new record into your table. So action goes as insert, and we have the table name over here. And how do we provide the values of the new entry? For each field, you have to enter the values of each field in this format. And the names of these XML elements corresponds directly to the table, database table field names. And here are the database table names: ID, name, form, street. Same you have to define here. So let's define a new custom ID starting with 4. This ID should not be there for us to insert a new record. If I go to the analysis, let's take the ID column. Let's see. So this ID is not available. We should be able to create this ID again. So let's trigger it. And in the response, we can see how many rows were inserted into the table. We inserted 1 record. Now we can see the data record that we added with the new ID. Now let's look at update. Let's say I want to update the name and the street of this newly created customer ID. And this is the XML format for updating. So action goes as update, and under access, you can just define which fields you want to update. I want to update name and street. And the new values I want to update that data record with. So this is the record that we are trying to update, the new ID that we created. Let's trigger it. We get the update count as 1. So the SQL statement should be successful. So if we go back to our database and if we refresh this, now we have the new values for the name and the street. Now let's look at delete. Let's say I want to delete this data entry. And here is the format. The action is delete, and in the key, we have to define which entry we are trying to delete. So let's execute it. We get the delete count as 1. Now if we refresh, the entry is now deleted. Now let's look at update insert statement. So this is also known as UPSERT. And what it does is, if an entry exists, it will update that entry. If the entry does not exist, it will insert a new entry to the table. So action goes as update underscore insert, and here we have to define the values of each field. And under the key, we have to define which entry we are trying to update or insert. So now we don't have this entry of custom ID ending with 4. Let's trigger this statement. Now we get the response saying the record is either updated or inserted. So it should have been insert because we did not have that entry before. But now we see that entry is now available. Now let's say I want to update the city of this entry. I can use the same action, update underscore insert. I can then change the city here. If I trigger it, we get a successful response. If I go to the database, now the city is updated with the new value Hamburg. So this action allows us to either update or insert an entry. And if you go to insert, if you try to insert another entry with the same key, it should fail. So you can see the error in the message monitor. There's an entry already existing with this key. So you can't use the insert operation. So this upsert is quite helpful if you want to either insert or update with the same statement. So up to now, what we looked at were single statements. That means we only had one single statement in the request. So to insert one entry or to delete or update one entry. But what if I want to create multiple customers with the same request? So for that, let's see if we can make use of two statements like this. I want to insert now two customers. And let's have new customer IDs defined here. Let's also change the names. Right. Let's trigger it. But we still get the insert count as 1. Let's go back to the database table and let's see which entry got created. So the entry ending with 15, where we had the name as Mark Fernando, that got created. Let's see the next one. So that was not created. So that means only one statement out of these two got executed. That is because in our adapter, we don't have the batch mode activated. So if you want to run multiple statements in the same request, you have to enable this batch mode. We'll go into the difference between the batch operation, atomic and non-atomic later. But for now, let's enable this batch mode. So I deployed the integration flow with the batch mode on. So now let's try to invoke the same. Now let's change the ID here because we already created that. Let's change it to 17 and let's trigger it. Now if you see, we get the response for each statement. So the statement 1 is successful. We inserted one entry, and the statement 2 is also successful. So if I go to the table now, 16 and 17 should be created. Right. Now you can see how to send multiple statements in the same request. So with this mode, not just the same action, you can have different actions in the same request. Let's say I want to insert a record and I also want to delete a record. So I can add another statement. Let's say I can add another delete statement over here. I will try to delete this customer. So this is the customer ending with 14 should be deleted, and let's create 2 new entries. So let's change this to 18 and 19, and we are trying to delete the one ending with 14. So let's set. So we have the response for all 3 statements. So the delete count is 1, and we inserted 2 new records. So let's see if the deletion has happened. Now the entry ending with 14 has been deleted. So insert is also successful. We inserted 2 new entries. So that is how the batch mode works. You can have multiple statements in the same request and also with different actions. Now we will take a look at under batch mode, what is the behavioral differences between atomic and non-atomic batch operation modes. We will still have multiple statements in the same request, and imagine a case where one of the statements is erroneous, is not successful. To simulate that, what I will do is, I will try to insert one entry that is already there, and then I will try to create a new entry. ID ending with 19 is also there. I will try to create this entry which is new. So one ID, I will change it to a new ID. So we are not violating the primary key principle. But this entry already exists. So this should give us an error. So let's trigger these 2 statements from the same payload. And we get an erroneous response back for the whole payload. And if we go to the message monitor, we can see which entry is giving the error. The entry with this ID right here. However, this one should be successful. Let's see if that is created in the database. So this is the new one. Still, that one is also not created in the database. So what has happened is, because we have one erroneous statement, even the other statement is not executed. So the whole payload has failed to execute. That is because we have the batch operation as atomic. Let's change it to non-atomic and let's execute the same request. So the same request, let's execute it. Now we are in non-atomic mode. We still get an error response. If we go to the message monitor, we can see the error. This entry with this key is violating the primary key. But let's go to the database and see if the new entry got created. Now you can see, even though one of the statements failed, the other statement that is successful got executed. So we created one entry. That is the successful statement over here. And this one failed. So that is the behavior between atomic and non-atomic. When it comes to atomic, if at least one statement fails, the whole payload fails completely. But in non-atomic mode, at least for SAP HANA database, the successful statements get executed while the unsuccessful statements errors out. But in both cases, we get an unsuccessful response back. So here is the behavioral difference in SAP Help itself. So in atomic mode, it updates the whole batch operation successfully or reverts the entire operation to its initial state. That is what we saw in the demo also. In non-atomic mode, it is based on the behavior of the database you are connected to. It updates all the successfully executed records and throws an exception if anything fails. Hope you enjoyed the video and learned something new. And if you want to download these formats, the SQL, XML formats that I used, I will leave a link in the description below. And if you want to learn SAP Integration Suite from end to end, I have a full online course that you can subscribe to. And I have over 150 plus lessons there under 28 chapters where I cover everything in a simple way. Doesn't matter if you are a beginner or have no prior knowledge in SAP integration, you can follow this course and become confident in SAP Integration Suite and cloud integration development. I will also leave the link in the description to this online course. Thank you for watching, and if you have not subscribed yet to my channel, please subscribe. I'm looking forward to bringing new demonstration and new topics every week.